All right, so we're Group 4 and we decided to focus in our project on the Wairau Valley and specifically the Wairau Valley Road. So as you can see in this image here, Wairau Valley Road is the green line running through here, and it's a main arterial road for the North Shore that provides access to both the motorways as well as North Shore Hospital. So it's a critical access line, especially during storm weather events to get people to emergency services. The area itself is a mixture of urban residential and industrial use. Most of the area inside the floodplain is industrial use. However, there are about 1,400 private dwellings located within the area itself, which serve about 5,000 members of the population. So within this area, flooding is a major issue, and it's mostly due to poor planning as the area is expanded, as well as the management of the Wairau Creek itself. So the area was really badly hit by the flooding back in January, as you can see in the image on the top right. The road itself was completely submerged and people weren't able to access the road whatsoever. The main reason for this is due to the urbanization and the congestion as the area has become mostly concreted and surface runoff has really become an issue. The Wairau Creek itself is an entirely concreted channel, which you can see down in the bottom right. And the problem is it was designed in the 1960s and just as of right now isn't sufficient to meet the current demands. So the solution that we propose to fix this is a hybrid solution based off the sponge city principles. We're going to incorporate nature-based engineering solutions such as revegetating the channel, installing bioswales along the side of the road, as well as implementing permeable pavement design.
The most evident of the present effects of climate change would be the Auckland floods earlier this year. Wairau Valley transportation infrastructure in the area suffered major losses with major road closures of the arterial roads and the regional roads in the area as well. The total damages for Auckland's transport network incurred by the Auckland floods was projected to be $390 million. Next. The Auckland flood was an unforeseen event, but will soon become more familiar as climate change increases in magnitude and frequency of flooding events. The Auckland floods were regarded as a 1 in 200 year event. However, climate change scenario RCP 4.5 predicts slightly higher levels of hourly rainfall, becoming a 1 in 20 year event between the years of 2031 and 2050. Next. As climate change advances, transport systems in Wairau Valley will also transportation systems in Wairau Valley are a greater risk. With increase in magnitude and frequency of these events, the amount of transport infrastructure exposed will also increase. This means more roads will be impacted and forced to close for repairs for extended periods of time. In doing this, the vulnerability of the community and the infrastructure itself would also increase, as the remaining open roads would be forced to deal with all the capacity of the whole system, and in turn leave the community way more vulnerable than it initially was.
So for our design solution, we want to turn Wairau Valley into more of a sponge city, and we want to do this using more sustainable urban drainage systems, as well as incorporating more permeable surfaces and vegetation cover throughout Wairau Valley. The permeable paving can be used along roadsides and within car parks, and the vegetation cover could be used as green roofs or just between buildings. So what more vegetation and permeable paving is going to do is it's going to slow down surface runoff, and it's going to increase the water's opportunity to evaporate, as well as infiltrate into the ground before it reaches the stormwater infrastructure, which currently doesn't have the capacity to deal with the fast water runoff due to the impervious surfaces. Next. So Wairau Valley is going to be suitable for this design solution, given its high area covered with impervious surfaces. As you can see in the bottom left corner, there's a lot of big commercial buildings, and it's pretty much all impervious surfaces on top of them and between them. It's also got a lot of high criticality infrastructure and lifelines, as discussed earlier, so we want to prevent water from getting and pooling on the roads and within the buildings. Now, the solution is going to reduce the risk that Wairau Valley has to climate change impacts by reducing the magnitude of floods. And so this is going to reduce the exposure of Wairau Valley, and in turn the infrastructure will be less susceptible to losses and damages, making it less vulnerable as well. Yeah.
One of the adaptation principles that has been incorporated into our solution is that the adaptation should focus on ecosystem-based interventions. As our adaptation is a hybrid solution, it incorporates nature-based solutions into an engineered design. For our chosen area of Wairau Valley, our design solution leans into a sponge city model. We have more means to deal with excess surface water, such as in a flooding event. This model focuses on ecosystem-based intervention, as much of this is done through things like revegetating channels, installing bioswales, and things like permeable pavements and roofs. Another adaptation principle that is being considered in our solution is that the adaptation should reduce vulnerability and increase adaptive capacity. With reference to the flooding Auckland experienced earlier in the year, our chosen area of Wairau Valley was especially affected by this. It highlighted the vulnerability the roading and infrastructure had to flooding and heavy rain events. Our design solution focused on reducing this vulnerability to the people and infrastructure through the sponge city model described earlier. By implementing a sponge city model and making sure there is ample surface water management when designing and building new infrastructure means a design solution such as this can remain adaptive for future changes as well.